Hello, friends. Welcome to the wonderful world of Backend 101. We're going to be learning about really cool backend stuff. So the primary goal of WDB is to have a full stack education, which is why we're having this backend primer. We won't dive as in depth as the backend track though. So if you want to learn more about the fundamentals, then go ahead and watch those videos on our YouTube channel. Otherwise, this will get you up to speed on how to do cool backend stuff. So the very first thing that we're going to talk about is APIs and REST APIs. And what exactly APIs are is how to access data from a server. And this could be any server. It could be from your web server. It could be from your own computer. It could be from AWS, something like that. But an API is just a way of accessing information, which is why it's called an application program interface. I think that's what API is called. Yes, application programming interface. So what an API is really useful in order to queue information and to have something set up. Why exactly are we? Oh yeah, you don't see anything. There are no slides. I'm just talking from memory right now. So we'll be doing live demos. So just stay tuned, friends. But yeah, actually in here, let me just drop this here. There you go. Application programming interfaces. So an application programming interface is this concept in software technology that refers to how multiple applications can interact and obtain data from one another. So that is the textbook Google definition. And the reason why this is so important is APIs make up the backbone of how web servers are accessed or how websites are built. So one big example is with Twitter, right? So Twitter has its own backend API that can access a lot of stuff. And this is all built using the Twitter API. So Twitter's front-end interface, so everything that you see on twitter.com, accesses the Twitter API in order to actually create things. So for example, all of these posts here is a request to the Twitter API, and then the Twitter API returns this data back to the front end. So this is extremely important if you want to find a way to display information. And this is where the front end back end split starts becoming a little bit fuzzy. So the back end engineers start building this sort of API in the back end in terms of code, in terms of how to send the data, in terms of what data to send. And then the front end makes it look really, really nice. So create this API request, get this data from the back end, and creates this website for, in our specific example, Twitter. So that is what we mean by an API, and that's why it's so important in the realm of web development. The specific type of API that we're going to use is a REST API. And to prevent confusion, I am going to Google a REST API. So this is restfulapi.net. This is where the core tenets of a REST API comes from. And there's several guiding principles of what makes a REST API. So we have client server, stateless, cacheable, uniform interface, layered system, and code on demand, which is optional, right? So all of these 6 things specify what it means to make a REST API. And REST APIs are important in that that's the backbone of how you're going to transmit data from the back end all the way to the front end. So let's go ahead and dissect what each of these 6 is. So what we mean by client server is that we get to separate the user from the actual server. So this is what we mean by the client server split, right? And this is where, again, the back end front end split starts to occur, in that the front end only deals with how to handle the data, whereas the back end deals with how to store the data and how to actually send and receive data. Next up, we have stateless. So one very key thing about a REST API is that it actually does not manage state. So all of the state is managed in the front end. So again, if we go to twitter.com, there is no state that the front end actually sends, or no state that the back end actually takes care of. The front end holds all of the state there. For example, what tweet to start off with and what tweet to stop. So these 1, 2, 3, 4, 5 tweets are dependent on what the front end API sent to the backend API. So the backend API doesn't actually care about what state you're in. The backend API only cares about how to represent that state that the front end API queued over. Also, let me open up chat real quick. Okay. Moving on from that, we have cacheable. So cacheable requests are extremely important because in terms of how we're getting a lot of data from a backend API, a lot of the requests are actually redundant. So if you remember from CS61A or from earlier this semester when you were taking 61A, we were talking about Fibonacci, right? So Fibonacci is defined by adding together fib of n-1 with a fib of n-2, and there's actually a lot of repeated calls. So fib of 0 is called numerous times, and fib of 1 is called numerous times, and all of those aggregate to your final fib of n number. However, what you've learned at 61A is that you could actually cache these results. So if you've already computed fib of 0 and fib of 1, you could store that information into your cache or an array, and then access that information later. That way, if you have two different calls of fib of 3 or fib of 5 or fib of 7, you only access the cache and you only compute fib of 7 one time, which saves a lot of time, a lot of memory, and a lot of headache. The same is true of a REST API. So if Twitter, for example, we refresh the page multiple times, 1, 2, 3, we can see that we got the same exact 5 tweets every single time we refresh. In addition to that, though it might have been kind of slow with the loading bar thing, Twitter caches these tweets in that we actually haven't scrolled down to view any more tweets, right? So these 5 tweets are saved on memory in your computer without actually having to go all the way to twitter.com. So if we're going to draw this out, let's go ahead and pull up Microsoft Paint. Boop. Don't save. Let's make up a new thing. So we're really using Microsoft Paint for this. Okay, we have Twitter's backend servers here, which will be TWI. You have your own computer here, COM, and then you have yourself, the user, right here. So you access twitter.com from this computer. If it's your first time loading up twitter.com, it will go ahead and go to Twitter and receive that information and store it on your computer. And then you get to view it back here. However, if you do the same exact request again, then Twitter actually saves that, your computer actually saves that information. So if you do the request a second time, you go to your computer, you don't go back up to Twitter since you already have that information, it just displays to you immediately. And that's what cacheable means in the specific case of a REST API. Any questions so far? Okay, cool. So moving on from that, next up we have uniform interface. And by uniform interface, essentially what this entire text means is that you want to store everything in a uniform way, right? So you don't want to have your own specific, if you recall from the Internet 101 lecture, you don't want to have your own specific set of rules for different kinds of media. So you don't want to have a different kind of API if you're sending text media, or if you're sending binary information, or if you're sending video files, and so on and so forth. You want it to be stored in one specific kind of format. In our specific format, the uniform interface would be a JSON file, which we'll go into later. Next up, we have a layered system. So you have a hierarchy of things in your API. So one key thing about the API is that in order to access that information, you have the same exact base URL. So twitter.com is a base URL. And then if you want to access different parts of your internal backend server, then you start adding more resources on top of that. So in our specific case, if you want to query the home page of your API, you can tack on home. Or if you have a recipes database and you want to get your recipes, you type in recipes, and so on and so forth. And that's a way that you could start building a layered system. So you could start adding layers, for example, recipes. And if you want to get all recipes, you type in all. Or if you want all potato recipes, you type in potato. Or if you want all duck recipes, you type in duck. And then you could keep adding more and more resources to get more and more specific. Of course, not all APIs do this. Some APIs are simpler than others. Some APIs are more complex than others. But in terms of having all of your information organized so that the user can access that, that's actually how you build your API system, by having different tiers and layers that delegates different kinds of access. So those are the 5 key principles of a REST API. As for code on demand, that is an optional, so we are not going to get into that, but that is essentially the guiding principles of what REST is and what REST does. Any questions for REST API so far? Okay, cool. Moving on. So this is what a REST API is. Now, how exactly do you access a REST API? And you could actually start accessing your APIs by doing HTTP methods. So just go to Google HTTP methods. These HTTP request methods are ways to actually request information for your API. And there's different kinds of methods that you could use in your request. You have a get request, a head request, post request, put request, delete request, and so on and so forth. The 5 key things that you're going to worry about, however, are these 5 right here. So a get request to get data, a head request to, actually no, maybe not the head request. It's just going to be get, post, put, and delete. So the get request to get data, the post request to post data to your server, a put request to update all of the data, and a delete request to delete the data on your server. So one big example is if you have a database on your backend. This is a very simple way to set up CRUD or CRUD functionality, which stands for create, read, update, and delete. With create, you post the query that you want into your backend. With read, you get that data from your backend. With update, you put that data into your backend. And with delete, you just delete that data from your backend. Of course, there's more HTTPS methods that you can use. For example, the head request, the connect request, the options request. But in terms of the core 4 that you will need in order to interface with your backend, it's simply, again, just going to be get, post, put, and delete. So those are your HTTP methods. There are more nitty-gritty parts of your HTTP methods. For example, the specific request URL, and that's where I was getting into with, for example, Twitter's recipes duck for having a uniform URL to query that. And in addition to that, you get the request body. So in terms of sending information to your backend, you put that into a body, which is stored in a JSON format, which we'll get into later. In addition to that, another key thing for requests are the status codes. So let's go ahead and do HTTP status codes. So in terms of the different status codes, there are different kinds of delineations of how your request actually went about. And it's very important to be able to handle different kinds of status codes and display these status codes in a very concrete format. So as you can see here, you have your 100 to 200, 100 to 199 status codes, and these are just informational responses. So essentially, if you send a request to your backend and you're still waiting on your request, it'll give you information about that request. So for example, the request was received and it's still processing the request, it'll return a 100 to 199. Next up, you have successful responses. So if your request went through completely, then you get a 200 response. And all of these other numbers are designated for different kinds of response types. After that, you get into redirects, which means that you must make further action to complete this request. So one example is if you forgot a password, or if you're missing vital information for your request, then it might send you a 300 by saying that, hey, I need more information, send a new request. Next up, you have client errors, which is 400 to 499. This just means that if you're sending a request, the server has no idea what the hell you're talking about and will just return a 400 to 499, meaning, again, it has no idea what you're talking about, and it was an error on your end in terms of making that request. Last but not least, we have 500 server errors. And the reason why we have server errors is, let's say that you send a completely valid request to your backend. Even though it's a valid request, the backend server might screw up somewhere and might accidentally crash. And this is where you get into your server error and sends back a 500 to 599 in order to figure out, or in order to notify the user that something went wrong and it's not the user's fault. So one example of HTTP requests is simply if you just go to web@berkeley.org. So this is a 200 request. It successfully went to the server and returned all of this information. You don't actually see the 200 requests. However, if you look at more tools, dev tools. If you look at your dev tools and you actually inspect how things are going on, then it's going to return no errors, no warnings. Essentially, it's a 200 request. In addition to that, one other key thing is if you go to a website that doesn't exist, for example, this website, we definitely did not program it in. So if you go into that, you get a 404 page. It says that you don't actually access the website, and it tells you that this specific resource does not exist. So this is an example of a 404 error, that this web page is not found. So those are your HTTP status codes, and those are how to get those HTTP responses. Does that make sense so far? Any questions?
Can you go back and explain where do we send these? Is this going to be in our code or?
Oh yeah, I was actually gonna get to that next, but yeah, you actually send this inside your React code or inside your Node code in order to handle these. So one big example is with Axios. So, or Axios React. There you go. Yeah, so with Axios, this is actually how you start sending these types of requests into your code. So this is a very simple version of Axios, essentially that you create a new component and you import Axios, and then you could start getting your GET requests, POST requests, or PUT requests from Axios. So in this specific type of example, you do axios.get, which mirrors your GET request. It sends it to this specific resource URL, so the URL that you're getting it from, and then you do stuff with this response. So that's the core of Axios. And if you want to change it to a put request or a delete request, you simply change in Axios this get to a delete or a put or a post. And that's actually how you receive this information from your backend, which is very important in how you're actually queuing up these sorts of APIs. Now, in the backend, we actually aren't concerned with sending these requests, but actually receiving these requests and handling how to receive these requests. So instead of actually queuing it, we actually build it from the ground up. So let's go ahead and do that right now. So I will exit out. I will open up your favorite text editor, whether it's Atom or Vim or Emacs. It is up to you. And we could start building a, oh God, what the hell is this? Oh, Artist Residency, which is a cool project that we did a few weeks ago. So let's go ahead and just make a new window. Okay, cool. So this is an untitled page, and we will, oh, I accidentally made two. There you go. And this is actually where we start building our backend API. So in the backend, like I said again, we're not actually concerned with sending these requests like what Axios does or what JavaScript does natively, but rather building the backend such that we could accept these requests and handle data as needed. So let's start doing live coding. We create a constant express, and we're going to be using express, which is a Node framework in order to actually build out these requests. So wait, first, let me actually save this to be a Node file or a JavaScript file. This will be called sample server.js. Oops. Okay, cool. There we go. So we require Express for our specific case, which is simply the module that you're using. We create a new app by just calling Express. And then after that, we set a port equal to, let's say, 850. And this opens up the port that we're using on our server so that people can actually access it. Next up, with Express, you create a new router. We're going to make something called a body parser. And this is just simply to parse bodies. It's just a helper thing so that we don't do it ourselves. And then after that, we have to specify that we're using these two things. Oops. And the next thing that we use is a body parser.json. Body parser.json. Also, this is not user, it is just use. There we go. So now that we set up our sample code there, we can start actually building out the requests that we're using in order to get things. So for example, one thing that we want to do is get a GET request. So with our router, we create a GET method here. We define this to be a regular resource, and then you create your callback in order to actually handle that resource. You have your request and your response, and then you can go ahead and do a bunch of stuff here. So for example, here we do response.json, which is just creating a new JSON object with a specific message of welcome to the sample app. So this is a very bog basic Express app in which it only implements a GET request. And if you call this GET request, then you're just going to get the very simple message of welcome to the sample app. So now that you have your base GET request, let's go ahead and actually start using this. So with your app, you start listening to your port number that you specified earlier. And you also want to say that your server is listening. Server online on port. And then we'll just append our port there. So let's go ahead and run this server, this very bog basic server with a sample GET request. Let's go ahead and where is, oh, there it is. Okay, cool. So let's navigate to where we put the server. I think I left it. Yeah, sample server.jsx. And let's go ahead and run this server. So wait, do I have node installed? Okay, I have a node installed. Cool. Quit. Control C. Control C. Okay, there we go. Okay. So let's go ahead and run this file. Node sample server.js. Insertion error, missing path. Okay, well, oh wait, I forgot to specify the path. Let's go ahead and fix that. Also, let's save this file. Ooh, excuse me. One thing that we need to do is actually start routing all of these things. So route. Oh wait, one more thing. Did I install Express? It's probably a good idea. Oh my God, I forgot to install Express. Okay, that's another very big thing. Okay, so wait, also, just curious, have you learned about NPM yet? Or like that sort of thing? In the front end before? Yes, okay, cool. Okay, so let's go ahead and just create this NPM app. Move all of this information into our JSX to sample server.js. Okay, cool. Oh, there we go. Okay, cool. Now that we are in the correct directory, let's go ahead and set everything up. Oops. Okay. What was the command again? It was npm. Oh, npm init. There we go. Package name, sample server, version 1. Okay, cool. So npm install express. Okay, and we will let it install express. Added 50 packages. Okay, cool. Sample server.js or npm sample or not npm node. There we go. Syntax error. Oh, I am forgetting. I spelled function wrong. It'd be like that sometimes. Okay, where did I put function? No. Okay. Okay, wait. My fat fingers have added some other stuff that I do not need. Let's see. So, yeah, we do not need semicolons. That is ready. Function. So that's closed. That's closed. Wait, what am I missing? Oh, it needs to be closed function. There we go. Oh, did it not save it? Wait, hold up. Function, Control S, Control S, Control S. Let's try this again. Oh my, okay, wait. Wait, why is it not saving? This is the same exact error I've been getting all this time. Okay. Let's try a different thing. Let us. Hopefully this will not give us the error. Cannot find module test. Oh, because I did not move it. Okay, wait. Move /test to here. Oh my god. Okay. Unexpected token. What? Okay. I am just going to copy and paste all of the starter code instead of type it all in. There will be extra stuff, but that is okay. Let us drop it here. Control S. Okay, so let's go ahead and try this again. Welcome to the sample app. Oh, I have no, okay. Oh my god. Okay. That is okay. I think you're typing sample server.js, not sample server.jsx. Okay, so I save this as test.js. It is requiring that. We have a set port, we have a router, we have a body parser, we have this set up, we have this to-do app set up. Port. Okay, let's try this again. HTML test5.js. Move that there, Control S. Okay, thank God. Okay, so now that we have went through that grueling process of fixing syntax errors, we could go ahead and allow access to this happening, and we can see that the server is online at port 8080. And again, to refresh you on what we did with the server, the only thing it does is it has a GET request right here, and it returns the message, welcome to the to-do app. And that's all it's doing. So now that we have the sample server, how exactly do we query the sample server? We back-end engineers love to use Postman. So Postman is this amazing thing that helps you test out your request that you're building, whether that is locally on your own machine or on your servers when you're actually deploying an API. So Postman just makes that really easy to query and test your servers without actually having to do anything on a code level basis. So one specific example is this WDB. Oh, let me not save these. Is this WDB GET request? You send it over, and then you actually see all the information that you have. For example, an internal server error. Or if you send it that, again, an internal server error. But whatever, that is fine. So in terms of creating these sample requests, you can go ahead and create a new request. Let us not save these requests and start entering the request URL. So right now we are running this entire thing on the local host, and specifically we're running this entire thing on the local host on port 8080. So go ahead and do a query request for that specific endpoint, which is http // at specifically the 880 port. So if you send a GET request here, then you have all of your information returned by Express. So we have done an error. However, Express actually pre-populates this information for us by getting the HTML data. So our actual request isn't complete. However, our actual port is running, and it actually can accept all of these specific kinds of requests. Again, so this is just Postman running in the background. You could actually do the same thing on your browser. So if you go to your browser, where is my browser? And you go to, again, localhost. Then it'll actually populate this HTML and show you this HTML. So as you can see, it's a specific kind of HTML. And it actually displays and shows this HTML, which is one thing that you could do with a request. In fact, if you remember from our RESTful API, so restfulapi.net, that is the sixth thing, which is code on demand. So this is functionality to allow the client to download code in the form of applets or scripts. And this simplifies things by reducing the number of features that need to be implemented. Again, what that means is that you could actually send code through your requests, like what Express is doing right here, whether that's in the form of HTML or actual runnable JavaScript. And then you could start running it just from a REST API, which is really, really cool in that you could actually have the backend engineers build the scripts for you. And then all you need to do is load those scripts up from the backend engineers, which is what a lot of companies are doing, specifically Twitter and Facebook and so on and so forth. And you actually might have noticed that if you have very slow internet, right? So for example, if you go on to gmail.com and you have very slow internet, which I sadly cannot show you right now. But if you have slow internet, let's see if there's a way to change the settings here. But essentially, if you have slow internet, then a lot of the cool features that Gmail has doesn't actually show up in terms of like the HTML being rendered, the scripts being rendered, and it's just a very bare basic HTML web page. So that is one cool thing about the code in demand. Again, this is optional, but if you want to go ahead and return specific kinds of HTML or scripts in your request, you're more than welcome to do so, as long as the front-end engineers know that it's a script being sent and can actually act upon that kind of script being sent. So I am going to go ahead and add more functionality to our current version of our API. Let me pull up my starter code. There it is. So let's go ahead and add more types of methods to use. This is just implementing much more stuff. And again, all of the starter code is on our Notion. So if you want to follow along, go to our Notion. So again, it's the same thing. We have a bunch of ports that we have implemented here. We have the same router. Again, we have our regular same GET request, and we have new resources. So one specific thing that we have is a to-dos, which is another kind of resource that you're adding to the end of your URL. So if you want to access these new kind of resource here, specifically to-dos, you would go ahead and just append that to the end of your URL and query your URL that way. So that's how that would function. And if you want to add more kinds of routes, that's all you have to do. Essentially, with your router, you add a new route by using this dot method. And then from that dot method, you can create things like a GET request or things like a POST request on top of all of this stuff. One other cool thing that you could do with your route is to do this specific thing right here. What this does is it actually pre-populates the URL for you so that you could have custom kinds of URLs by adding this. Wow, I really don't remember what this thing is, but the double dot thing, the colon thing, by putting that in front of that, then you could actually start adding IDs. So what I mean by IDs is, for example, on a real life use case with Twitter, if you go to twitter.com and you actually, for example, go to a specific user like Calban, for example, then this is a very specific kind of URL request in that you have this specific ID that's tied to specifically Calban. And you could actually build your requests in such a manner that it returns these specific kinds of people. So if we want to implement this kind of system in our own backend API, instead of doing, for example, get this, one other thing that you could do is tack on this kind of route over here. So router route, to-dos and your to-do ID. Instead of doing to-dos, you can just route this all the way down to user ID, where this specific user ID is replaced with Calband or whatever type of Twitter username that you want, or in our specific use case, whatever to-do ID that you want to replace this with. How this is reflected in the URL is instead of putting a to-dos here, like for example, in our React app, we have it as, also let me delete this so that you don't get syntax errors. In our request, we have to-do ID here. You don't actually put to-do ID. You replace this to-do ID with the actual ID of your to-do, whether that's a number like 12 or maybe they spell it out like a random hash. That's where you would put that in the URL, and it would actually get routed correctly in your backend using Express. Oops, that is not what I wanted to. Okay, cool. So yeah, this is what this specific kind of syntax means, and that's how it's requested and actually updated using this specific API. One more thing is that notice how we have our regular suite of methods that we implemented. So at first we implemented the GET requests up here and here, but then we could add the POST request and handle the POST request, or a delete the request and handle the delete request. Again, this is an extremely basic type of app in which it doesn't actually do anything in the back end. But if you have something like a MongoDB database or a SQL database, then that's where you actually start running the functions instead of running messages. So one big example is instead of like just returning this message, you would do stuff here, like, for example, actually delete the to-do. And that's where you would actually run that code. And that's how you would have that code running in your backend server. So I've been talking for around 40 minutes straight. Does anybody have any questions while I drink some water? Okay, cool. No questions so far. Very cool. Very nice. Okay. So that's the very basics of Express, and I apologize for the technical difficulties that we've had earlier. Now you're wondering, how exactly do we host this type of this type of server on a different machine than our own computer? So right now we're running everything on our local machine, specifically localhost, and on a specific port of 8080. And that's not necessarily the fastest way to do things or the most easy way to deploy things, especially if you have to drop into a server. So that's where we start using cloud fundamentals in order to do that for us. So one of the easiest ways to do this without actually buying your servers is to use AWS. So let's go ahead and pull up AWS. So right now you don't have any AWS access to our own personal org. However, for the next homework, which is backend primer homework, we'll be giving you AWS access so you could host your own sample server. So here in AWS, we can go ahead and spin up what's called an EC2 instance or an EC2 server. Don't worry about the nitty-gritty details of what EC2 is or how to do EC2. Just know that it is something that you can access and something that you could spin up to easily host your servers. So let's pull up EC2. You can launch your own instance by clicking this orange button right here. So you could launch an instance from EC2. We're going to be using a Linux EC2 instance. Don't worry about what these other things are. They're not important. The only thing that we want to do is just to host our sample server, and we could just do that with a very simple EC2 instance. In addition to that, we're going to choose the free EC2 instance because, again, we're just doing the bare basics right now. We're just hosting a web server. So let's spin up a T2 micro, review and launch it. Launch. We will all right, let's go ahead and launch this instance. View instances. And then now that we have this instance running, we could actually log into this instance once it's done initiating, and then start moving our server information into this instance, and then actually queue it from there. So it is now running. You would click your instance here, and this is the specific IP address that you're going to. So go ahead and copy this IP address, and then go again onto a terminal. Let's go ahead and stop running our previous npm instance. And then we could do something called SSH, which is SSHing into your specific instance. So let's go into downloads. If you remember the name of our key, I think I called it yet another, where is it? Wow, I completely forgot what key I used. Hold up. Does another key pair that I have to delete? Okay, so in order to actually access your EC2 instance or your own personal server, you go ahead and SSH into it. The thing that I downloaded was a key, so you need a specific key to log into this instance, which is good because you don't want anybody to log in. So you would just specify ssh.i, whatever your key is. In this specific case, this is the key file that I used. Next, you log in with the username ec2-user, and then you go into the specific URL that you copy and pasted up here. So let's go ahead and copy this address, drop it here, and then you can SSH into your instance. Note that we are now in our specific instance, and this is just like using your own computer with your terminal interface, except, again, it's somebody else's computer instead of yours. Notice that whenever that you create a new EC2 instance, it's almost like buying a completely brand new computer. You have to install Node. Like, for example, Node isn't necessarily installed just yet, and neither is the rest of our things. Or, for example, Express, you still need to run npm Express. But again, we also don't even have npm installed. So you would have to install npm using your command line interface. So if you want to do that, you would do install node using terminal. And then you could actually install using the package manager, depending on what you want to use. one thing that I want to say is that there is no homebrew on this. You have to use yarn, or not yarn, yum, in order to install anything on here. So yeah, yum. So you would have to yum install npm, yum install node, and then after you're done with that, then you could actually go through with implementing your server. So if you already have your own Express server or you already have your own Python server, then that's how you would migrate everything into this server and run everything from there. And this is where you start configuring your own domain name, start configuring what port you want everything to run on, and actually building out this API. Now, one thing to note is that me as a developer, with the ongoing march of technology, I actually haven't deployed any APIs using Express because a serverless architecture exists instead. So if you want to spin up a very quick and dirty API that's very functional, then for me at least, I don't use EC2 and Express. I use something called a serverless architecture, which uses Lambda, API Gateway, and DynamoDB, all of which is on AWS. I actually won't get into the nitty-gritty details of how to do this until backend 2, but I guess that's something to stay tuned for the next installation of this backend series. So for now, does anybody have any questions? I know that was a lot of information dumped on you all at once. So if you have any questions, totally understandable.
Can you re-explain how the AWS thing works? Is it like we're borrowing a temporary server, or?
Yeah. So with AWS, I won't get into the nitty-gritty details of how AWS functions, but the only core thing that you have to know necessarily is that AWS will let you borrow some of its compute space, aka the specific kind of server, and then you could use the server with your own needs. The server that we borrowed specifically has certain types of details. So let me pull up these instances. So the server that we're borrowing is a Linux server. And in addition to that, if you want to get to the hardware, we're using one virtual CPU, 1 GB of RAM, and instant storage. Don't worry about what EBS means. Just know that you have some storage available to you. So this is just what you're borrowing from AWS.
So are we borrowing it only to test our app, or is it like we borrow it indefinitely as long as our app is out?
Yeah, so this is a instance of borrowing it indefinitely. So as long as you want your server or your API to be run, then that's how long that you'll have this instance. So for example, we're not actually running this kind of instance. So what we can do is just delete this, right? So if you go into instance state and then you terminate your state, then that would actually delete the instance. Also, since this is a free AWS account with a free AWS instance, you don't actually have to pay for anything. However, if you want more beefier instances, for example, more CPUs, better networking performance, then you would actually have to pay for that. And you pay hourly in AWS. I will also terminate these things since we're not using it. But yeah, that is the basic nitty-gritty stuff of actually hosting your Express server on the cloud or on the internet. Any more questions? Okay, it doesn't seem that there's any more questions. So here, I'm going to do a live demo of how Postman works. So let me just clear all of this stuff. So one specific thing that I use Postman for is, again, to test out APIs. And I actually have this API ready that I use for a project that I'm working on. So let me go to that. Not I am. And again, we're going to be learning about how to use API Gateway in the next installation of Backend Primer. But these are a bunch of sample test APIs that we're using. Specifically, I'm going to use this API. So, and also, if you want to try this at home, this is actually open to the public. So you could actually like query these APIs if you have the correct information. So let's go ahead and deploy. Yeah, so this is the specific URL that we will be invoking. This is the API invocation that we'll be using. If you want to, again, use it, go there. So if you go to Postman and replace this GET request with tutors, and then do a GET request there, then it will actually return information back to you. However, it is forbidden. Let me fix that. Resources, tutors, GET. Let me turn off the API key. Deploy API. There we go. Let's see if it, give it some time. It takes some time to regurgitate. Okay, there we go. So this is the an example of a request that you're getting from this API that we've built. Notice how that we just put a tutor value here. These are the specific kinds of resources that you're accessing, whereas this is the base URL that you're basing your entire API on. In addition to that, you return everything in a JSON format. So notice how, again, the content type is a JSON. If we want to view it raw, it just returns everything into a giant string, and then you actually have to parse the string into JSON. But again, if you remember from our Atom, there are actually things that do that for you. For example, a body parser or a JSON package that actually like parses this JSON and converts it for you. But the core requests, like if you have it left as a raw request, then it's given to you in a giant block of zeros and ones or a giant block of text. So it doesn't actually look very pretty from this standpoint, which is why we usually pretty print it. But again, notice how everything is in a JSON format. You have this giant unstructured JSON that has a list of items inside it with a bunch of variables or fields that are returned to you. So the thing that I like to liken this towards, or what I like to liken a JSON towards, is a Python dictionary, right? And you could think of it as a dictionary of dictionaries of strings and so on and so forth. So inside a JSON, you could actually have arrays, strings, numbers, that sort of thing. And as long as you could convert everything into a nice text file after, then you've actually done this correctly and have actually built out your API correctly. So this is what a standard request would look like that is returned to you. Now, this is really, really freaking ugly in that, like, it is a giant block of text. There is a lot of stuff. So how in the hell are you supposed to actually display this information? And that is actually the job of the front-end engineer or the designers or what you're doing right now in the front-end track. So with this information, then you can programmatically start building your website in a beautiful manner that'll actually show the client what they want to see. So this may be the backend API. This is a raw request that we're getting. However, if you go to the actual website that it's using it, where is it? Advanced. If you go to the actual website that's using it, everything is placed in a nice format. And this is actually what your job is, to take all of this messy raw data and then place it into where it will actually look good in a website. So for example, for each of these items, figure out where to display the phone number, where to display the university, where to display the YouTube link, and actually do everything with this information to make it look like it's not doing any of this gross backend stuff after all. So we have about 25 minutes left. I would start doing the serverless architecture, but to be quite frank, we don't have enough time to go over it. So I honestly might just end this early. But if you have any questions, I will remain on call if you need anything. In terms of this backend homework, I'll probably release it either Tuesday or Wednesday, and it'll be due a week after that is due, or after that is released. So again, thank you so much for peeping into this backend lecture, and I will hope to see you again whenever I do backend lesson number 2.